Okay, so we do this by democratizing the knowledge of artificial intelligence, and then okay, so sorry, I was cut off for some minutes. Okay, so we have the facilitator already, and then I would like him to take off immediately after the introduction, just a brief one, so that we can have enough time to take the section. Okay, so with our vision to raise 1 million AI talent and build a product that will impact the well-being of the 2 billion people in the emerging market, improve the well-being. I'm sure we know that we have communities, uh, uh, both city and campus communities, and that we can all join. My colleagues will be dropping the links to join our communities and in the chat box. Okay, so don't let me take a lot of our time. I want to confirm, Lawrence Okegbemi, are you there? Can you just unmute?
Yes. Good afternoon. Apologies for joining late.
Okay, so I'll be handing over to Lawrence now. I think we spent a lot of time getting the table set. Okay, so Lawrence will be sharing the screen very soon so that we can start the class as soon as he's able to get the slides on the screen. Okay, so over to you, Lawrence, please.
All right. Good afternoon, everyone. Once again, I sincerely apologize for joining in late. I actually run late on some couple of other meetings I was having. All right. So people allowed to talk or comment or something? Just want to confirm from you. Teju. Hello, Tejumala, are you there? I just want to confirm if people are allowed to comment or just ask me a few questions as we move on. Is that allowed? Teju, your mic is currently muted in case you're talking. Okay. So since we are not able to hear Teju, feel free to, when you have any question, feel free to drop in the chat. I will just open the chat. There is no audio. All right. Okay. Okay. So feel free to, just drop in the chat if you have any question, and I'm just going to attend to your questions. All right. Okay, then if you have any question, you can, just signify, and then you can, be given access to talk. All right. Let me quickly. Yes. Hello.
Hello. Yeah, this is Emmanuel.
Hi, Emmanuel. All right.
Yeah, I'm joining for the first time.
Okay. Oh, nice to have you here, Emmanuel. So nice to have you. Okay, great,
Yeah.
Emmanuel. Awesome. So hope you've been attending other sessions as well.
No. Today is my first
All right.
time.
This is your first time. Okay.
Yeah.
Well, I believe that this is definitely going to, be a good one as well. So nice. It's so nice to see everyone joining from different places. Okay. So hope you can all see my screen. So basically what we want to discuss today is sentiment analysis using Python to classify movie reviews. Okay. And like I mentioned once again, it's going to be interactive. So in case you have any question, feel free to just drop a comment, and we are going to go as basic as possible so that you can actually understand the nitty-gritty that is needed for you to pick up sentiment analysis project and work your way around it. So sentiment analysis is something that is very important, especially when it comes to text. When you are dealing with text analysis or something, this like sentiment analysis is like one of the projects that you will actually come across, and it's very, very interesting, to be honest. So all right, what exactly is sentiment analysis? Okay. Sentiment analysis is a kind of analysis or a kind of approach that you take in order to understand people's opinion. Let me just, I'm giving you this definition on top of my head without, I want to make it as simple as possible. It is, you use machine learning, you use text analysis, then you use opinion mining, which these are like techniques that you use, all right, in order to understand the sentiment of somebody, all right, or let me say how somebody feels, all right, their expression about certain things. Okay, a typical example will be, if you download a lot of apps from Google Play Store, will be when you actually see reviews and you see negative reviews and positive reviews. These are like typical examples of sentiment and analysis. These are sentiment analysis in action. Now, the one we are going to be dealing with today is using it to classify movie reviews, right? You want to know what, for instance, after watching, there's a common popular film now in Nollywood, Brotherhood or something. So after watching Brotherhood, right? What is your sentiment about it? What do you think? Do you think maybe you write a review about Brotherhood or something, and then you just said, okay, maybe you have set of people from cinemas that watch this film and ask them, what do you think about this movie? What do you think about that movie? And then you decide to run or get their opinion, right? So their opinion can either be negative or positive. Some might even be neutral, okay? This is like, something on the basic level that this is like, something around sentiment analysis. Okay, so I hope you actually understood what I've said to this stage. Kindly, just drop something in the chat so as just for me to confirm that you guys are actually following me. Okay, so let me just wait for you guys to drop something in the chat. Okay, cool. I could see from Dorcas, she's following. Cool. So essentially, that's sentiment analysis for you at a basic level. Okay, for you just to understand what sentiment analysis is all about, because it might look like, what is this? As we're going to see, you're going to definitely be using Python, all right, to actually classify movie reviews into this class. Okay, cool. So let me share my code screen. Give me a few moments. Let me share my code screen. Okay, I'm coming. All right, so I'm just trying to share where we have our code for today so that we can, start working through it together. Okay. Okay. Please let me know when you can see my screen. I would like to confirm if you can see my screen. Just let me know once you can see my screen. Okay, let me just close this. Can you see my screen? Sorry. Trying to make sure we only have just one. Okay, I'm still here, trying to figure it out so that you can all see what I'm trying to share properly. So I want to close some of my screens. Okay, so let me check. Yeah, you can see my screen now. Cool. So let's start from the very, very beginning. And then, so I decided to use Colab. I'm sure most of you must have been familiar with Colab. Colab is an environment provided by Google for you to quickly run, your Python, or maybe you're carrying out your data analysis or anything you are doing at all, most especially in data science and machine learning space. You want to get started maybe using Colab because you don't want to do all those manual setup by yourself, because this is like an environment that, you can quickly use to like run whatever you want to run. Like I said once again, because we are going to be using Python for this, the level at which we are going to go is not going to be, we're not going to get to using neural networks, using deep learning approach. We're just going to stick with classical machine learning, and you're going to see so that you can actually understand some of the things we are going to be doing. Once again, like I said, sentiment analysis literally just has to do with opinion mining, right? This is like one of the basic things you do with sentiment analysis. You try to understand people's opinion about certain things. It can be a product, but in our case today, we are dealing with the movie reviews. Okay, and the data sets we are going to be using for us to just jump right in will be the IMDb movie review data set. Okay, now just before we actually go in depth to that extent, I just want to like show you something very quickly, which is like a layout, all right, of some of the things that you do. Okay, let me see if I can maybe have a whiteboard just to do some annotation on what we want to do. Let me see. Can I get annotations? I cannot. Okay, I don't think I can annotate, but then it's fine. So of course, you know that most times in your machine learning approach, whenever you get a data set, maybe either through scraping or maybe you have an application database that you're fetching data from. Okay, the first thing you want to do in that case is to actually understand your data set, right? Very quickly, let me see if I can actually, open up Miro and try to see if I can quickly just put some things together diagrammatically. Give me a few moments. Let me see. Okay. Just okay. Seems this is full. Okay, let me just try to log in with a different account and try to see if I can Cool. Because I would also like to just, put this thing together and let it be as interactive as possible. Yeah, I can't find the annotation feature. So that's why I want to just use Miro for just to quickly show some things. So I'm going to be using this. Let me just open this. Also I'm going to be using okay, cool. So on this, this Miro, let me just try to, okay, we're going to maintain this board. We're going to do something real quick. I'm trying to get, okay. Cool. So I'm going to move to this place, right? In your classical machine learning, whatever you're trying to do, okay, I don't think, okay. So I think I don't also have an edit access because this board is not editable. Okay, so I'm going to open one, which should be editable. Just trying to illustrate certain things so that you can actually get what I'm saying. Okay, so don't mind whatever is written here. Okay, cool. So in your normal machine learning approach, this is what we are going to be using. And I want you to look closely at this because what we are going to be doing with sentiment analysis has to do with text analysis. Okay, when you talk about sentiment, first thing that comes to your head is, first of all, you have a bunch of text that you are dealing with, which can be reviews, which can be maybe tweets, okay, which is another very common example that people use. Okay, you have tweets, you have, it can be reviews, it can be comments, script from social media. So all of these things are what we use. So in your normal machine learning approach, what the first thing you do is data collection, right? You collect your data. Okay, I want to use this as a typical illustration as to what we'll be doing at the end of the day, because this will come in handy and going to be very, very important, in understanding some things that we're going to be talking about. Because when you talk about sentiment analysis or even text analysis, okay, in general, there are quite a couple of things that you have to really take note or you have to do, okay, before you get to the final destination. So it's very important that you actually understand each of these steps. Okay, we are going to write the code. We are going to walk through this code that I've written here together. We are going to write that. We explain line after line, but it's very important that you also understand, this thing from a very theoretical point of view, so that it's easy for you to replicate it and also apply the same technique even when you are using other approach. Maybe you're using deep learning approach or something. So the first thing you do, of course, is data collection, okay, followed by, okay, when you get your data, what else do you do? Okay, you try to and your data collection is something that was informed by problem statements, right? You actually formulated your problem statement, which is what actually informed how you want to collect your data and all. Then, of course, you have your data analysis. Okay, from your data analysis, or let me just call it exploratory data analysis, which is EDA for short. Okay, where you try to understand what's going on with the data and all. I believe that you must have seen some of these things before, but then just for the sake of refresher, for this thing to actually help us as to where we are going is why I'm trying to repeat this again. Now, from EDA, then you do your features engineering, right? You do your features engineering. Actually, what I'm giving you is something that you can have sub processes. Okay, you can have sub processes. When I mean sub processes, for instance, part of your EDA might involve something that I did not include here. Okay, of course, in EDA, you would want to understand the data. Your EDA might involve a mini transformation. all right, on the data in order for you to like quickly analyze the data and get a better understanding from it. Why, of course, your data engineering as well has lots of things embedded in it. There is transformations, you have transformations and scaling, you have scaling, you have transformations, you have all of these things that you can do in your features engineering. Then when you are done with your features engineering, you move on to modeling, right? You move on to modeling. And then from modeling, you can, of course, where you actually, you do your model evaluation, okay? You try to use an evaluation metric to understand the performance of the model. If you notice that maybe the model performance is not great enough, you might want to like reiterate the entire process, maybe change some hyperparameters. If you think that the model is still not improving, you want to start from the beginning, which is, okay, look at your problem statement. Do you think you actually, or the problem was actually formulated properly? Okay, and then from there, let me just, write this here, or just to show something, which is problem formulation. Formulation, okay, where you formulate your problem, then you try to see which of these stages might have been having issues, right? So this is like a typical, machine learning process that, is something very basic enough, okay, that I'm sure you must have been familiar with these, steps. Let me just call it steps. There are several names you can call it, okay? But for now, I'll just call it your ML steps, really. Yeah, there are a couple of other names you can call it. You can call it pipeline, you can call it, but I'll just call it ML steps, okay? This is what is needed for you to like get anything out in machine learning. Okay, when I mean anything, well, yeah, a lot of things. Let me say, yeah, a lot of things. Let me not say everything. So in machine learning, this is what you do. Okay, now for sentiment analysis, which is like what we are trying to deal with today, the data we are using in terms of data collection, all right, the data has been collected already. Okay, it's IMDb movie review data sets we are using, okay, which was like a data set that was gotten, from an application database. Okay, well, that same data set can actually be obtained as well from scraping. Okay, either way. Okay, of course, when you look at our problem formulation is to understand people's opinion, all right, on the movie or movies. Okay, we want to actually understand public opinion on movies. Okay, so that's like our problem formulation. That's like our problem statement. That's the problem statement we have at hand. Now, you can do this manually by, of course, reading through each of the data one after the other. A wonderful, little production, and keep reading. I think we have one here. One of the author reviewers has mentioned that after watching just one, you can read this and do this manually. But of course, we understand that, because of all these tedious tasks, is why machine learning exists. Okay, so quickly help us or provide solution to it. Cool. Okay, just checking the comment section to see if there is any message or any question or anything that I can quickly just attend to, but I'm sure this is something you're already familiar with. But if you think there is anything you don't understand from what I'm saying, or you're lost somewhere, please just signify, and we like to, just attend to the question straight away. Then we move on to the EDA section, all right, where, we'll talk about, what does this data actually contains, because from the EDA, okay, we try to understand is the data balanced or it is imbalanced. Okay, we want to understand what are the things that are in this data set, because these are like some of the things that we inform the kind of features engineering that we are to do. So don't do your machine learning blindfoldly, okay? There is an approach to all of these things, okay? You don't just jump in to go and just do features engineering, okay? There are certain things from your EDA that will inform the steps, the techniques to use when you get to features engineering, okay? For instance, maybe you have, just like something I worked on a few days ago, right? So I have a data set where the column is a temperature column. Unfortunately, when I actually inspect the data, I was seeing, and it was an object column, all right? So it's not supposed to be, it's actually supposed to be float, okay? But it's actually object. So what I needed to do was, okay, before I actually pre-process that data, okay, maybe I want to scale the data, maybe I want to do anything. No, I'm just saying, I needed to like understand why is that particular column, why is it an object? Because it is supposed to be. I tried converting it to float, but I actually got some errors. So I knew immediately that definitely I have, I have strings, okay, I have text in that column. And what I needed to do, it was, of course, during my EDA process, I had to like, really bring out, try to use Pandas to filter out the columns, the rows that actually contains, this string data, right? And from there, I actually converted them to none, right? So that I could actually fill it in, because that is, I assume that part or those rows were actually, maybe they were fitting by mistakes, or maybe they were omitted. All right. It can be due to any error. So I decided to like just leave it as not a number. So then from there, I decided to like apply. I took the mean of the column, then I actually fill it in, right? With that with the missing values. So these are like, so I did not just jump to the features engineering, I needed to do the EDA. So the same thing, you are going to see what we'll be doing today as well. Or you need to understand that, okay, the EDA is important before the features engineering. Then afterwards, you go to your modeling. Okay, here you can now start talking about the different models you want to use, or different algorithms you want to use to build maybe logistic regression, most times, okay, so maybe just for people who have understanding on, maybe a few understanding on modeling, most of the time, when you talk about sentiment analysis, you are basically going to be doing a lot of classification, not regression, okay? Like they are not, most sentiment analysis are not like a regression kind of problem, they are classification, because you want to understand opinions, okay? Or you want to mine opinion, you want to actually understand how users feel. Is it negative sentiments, positive, neutral, you can have other categories as well, depending on, how you formulate your problem, all right? So the modeling part, most of the time we use, we do it like just a normal classification task. That's the way you do it. But you know where the difficult part is? The difficult part, all right, which, led me to explain all of these things again to you, is the fact that we are dealing with text. Okay, we are dealing with text. Now, your computers, and that's why, let me not use your computers, let me say your models understand numbers, right? They understand numbers. That is why you notice that from the previous classes that you've had, when you want to train a model and you notice that a particular column has, categorical variables, right? You convert them, maybe you use label encoding, you convert them to numerical, right? So exactly. So now you have text. How do you convert this text to numbers? Because it is the numbers that your computer actually understands, your model actually understands. Your model does not understand a wonderful little production. The model does not understand this. You have to, do a kind of numerical representation, all right? Which is like, what really forms the basis for embedding word vectors. This is something that you are going to be hearing a lot. You will hear things like word vectors, you hear things like embeddings, okay? Especially when you get to the natural language processing domain, which is where sentiment analysis actually falls into, all right? Okay, so let me just ask, any question? Does anybody have any question or anything? Any question or something to ask? Okay, does anybody have any question at this point in time? So I believe you're taking notes of some of these things I'm just explaining, because you are going to find out that these things will become very useful to you. Okay, I could see people raising their hands. Okay. Please, can you, okay, how do I expand it? Okay, Paul, you are the first person I'm seeing. Okay, I think you should be able to. So Paul, I think you can unmute and talk.
Hello, good day, everyone.
Yeah, good day, Paul.
Yeah, I just joined in I just got the mail to join in, and I just got here and I really don't understand what we are talking about. So
Okay.
I wouldn't know if I'll be dragging you back by asking my question. So
Okay,
but
cool.
still, since the floor is open, I just said, let me ask.
Cool, nice. All right, welcome. I will do justice to that very quickly. But is there another question? Anyone wants to ask that question? Yeah, Adekunle.
Yeah, good morning. Can you hear me?
Yeah, sure, loud and clear.
Okay, what I want to ask is for this, like what we are doing now, like the model we are going to use, like, is it just the classical machine learning, or we are going to like using the NLP models, or just the normal machine learning models?
All right, so I understand what you're saying. So I think your question is more, so we are not going to be using any deep learning approach once again. Of course, if you're doing, NLP, you use machine learning models. So we are going to use naive Bayes, and we are going to use logistic regression. Essentially, we can use XGBoost as well, but on the basic level, we just want to make things as easy as possible. We are not training neural networks, okay? At this point, we are not training neural networks, because it is very important that you understand the foundation. Because neural networks, if you want to get into neural networks and deep learning techniques, those one also comes with other things that you need to actually understand, okay? For instance, we might not be using just our NumPy. We might want to use TensorFlow or JAX, or maybe PyTorch or something to do that, which is what we don't want to get into, because it's definitely going to take a lot of time. I hope that's clear, adequately. Okay, cool. Okay, there is Neil or Techno Pova Neil. So let me just ask you to unmute. Yeah, you can talk, Neil. Yeah, you're currently on.
Hello?
Yeah, hello.
Hello?
Yeah, we can hear you. Go ahead.
Okay. I'm a kind of lost here. Like, I don't know. I just joined in today. So
okay.
I'm just like novice over everything.
Okay.
But I'm just following quietly.
Okay, cool.
Yes.
I'm sure you are going to learn something. At the same time, Babatunde has dropped, the link to DSN YouTube channel, all right, in the chat. Kindly check it out. And I'm sure you are going to learn a lot from that channel when you open it, because there are a series of, classes that has been held in the past and have been recorded. So try as much as possible to go through those classes. I'm sure you are going to learn a lot. And there are a couple of other, events there that can, give you more exposure on as pertaining, data science and machine learning in general. Okay, is that clear?
Yeah, thank you.
Cool, but you can still, stay around and try to learn. Okay.
I'm around.
Sure. Okay. Grace. Let's hear from Grace.
Good afternoon.
Good afternoon, Grace.
Hello.
Yeah.
So I'd like to know quickly.
Please, because of our time, I would just like us to use the chat for our questions. Okay, so that we'll be able to cover much. So everybody will not be allowed to unmute, so that we can just focus on what we have to do. You can just drop your questions in the chat. Thank you.
Okay.
You can go on, Lawrence. Yeah.
Yeah, I think that's a better approach. Thank you so much, Teju. Thanks for bringing that up. That's a better approach. Okay. Please, Grace. Please, can you just use the chat? I will be opening the chat at intervals, and now so that I can attend to your questions. But please, I think so that it's fast as much as possible, just put your question in chat. But I'll be on lookout for that. Okay, cool. So working with Google Colab, this is one of the things you have to do if you really want to get your data into something that you can actually use in this environment. There are several ways to do this, but the first thing you want to do is to mount your Google Drive. Okay, Let me do something. I'm going to disconnect and delete this runtime so that you can actually see how this thing, how we can restart this thing. Okay. So from Google Colab, from Google.Colab, import drive. So this is just like a Google thing. You want to configure your Google, you want to mount it, okay, to your Google Drive. So let's do this. It's going to ask you for permission, and you are going to, click on allow and accept everything so that you can access your files. You can access the files in your Google Drive. Okay, that's the main essence. That's the reason we are doing this. Okay, it's just going to take a few seconds, and that's all. So we needed to do this configuration basically. So let's just do it, and once we are done, so we're done. Okay, so just for you to know, the IMDb data we are using, okay, I actually downloaded it from Kaggle. Kaggle is a platform. It's like a data science platform where the competitions, machine learning competitions and data science competitions are being hosted. It also has a section for data sets. So you can go to Kaggle and just type in IMDb data sets, and I'm sure you are going to get this data set. So in case you want to follow along, IMDb data set. Yeah, so you can download this from Kaggle. There are a couple of other platforms that also have this, but okay, you can download this thing from Kaggle. Okay, cool. So let's change our directory so I've created a directory called sentiment analysis. This is something, if I open sentiment, okay, I think I've opened this before. But the idea is that there is a folder, there is a Colab notebooks folder. Automatically, when you create a, let's say for the first time, you've not used Google Colab before and you create a notebook, okay? So create a notebook, just go to colab.research.google.com and you can do this, okay? Automatically, you have a folder named Colab Notebooks, and inside it, I actually created another folder called Sentiment Analysis. Okay, so I'm going to run this as well. So now I can actually access anything or all my files that are in that particular directory. So let me just do this. So as you can see, I have my imdb data.csv. Okay, I have the PowerPoint file there, right, which is like the one we looked at first. Then we also have this sentiment analysis with Python IPYNB, which is this file itself. Okay, so enough of the setup. Let's start going into our code and let's start understanding how this thing actually is structured. Okay, we import pandas as PD. Okay, pandas is a library that is used for handling tabular data sets in Python. Okay, so that's what we are going to use it for. We are going to use it to read in our IMDb CSV data, okay, into a tabular format. And of course, you have NumPy, okay, which is like your linear algebra library. So we are going to be using NumPy as well. And then, so this is where the whole thing starts getting interesting. We are going to be using regular expressions, okay? We are going to be using regular expressions to remove punctuation, okay? To remove punctuations. You're going to see as we progress, okay? Because it is very important that, we're actually dealing with text. So regular expression is a library, is an inbuilt, like is a Python standard library. You don't have to install, RE, which is regular expression. You don't have to install it. It comes with your Python. Okay, but if you're on your local machine, you have to install Pandas. Of course, you have to install NumPy. However, if you already have an Anaconda, you don't need to, do most of these things, installations that we're going to be importing. You don't need to do all of these things anymore. Okay, so we are going to be using matplotlib and Seaborn for plotting. You can either use any one of them. Most times, I find Seaborn quite straightforward. However, if you're just getting started with visualization in Python, I still advise to go ahead and learn Matplotlib before learning Seaborn. But sometimes you want to quickly get things done, you can use Seaborn. Matplotlib gives you a proper understanding of how your plotting library and all of those. I mean, how plots should be configured and all of those things. Okay, cool. Since we are dealing with text again, we are going to be using Beautiful Soup, and the idea of the Beautiful Soup is that we are going to be using to to actually clear up or clear this or HTML tags. And something we actually notice that something will become very interesting when we get to this list. And it's with this now, it obviously shows that this data was actually scraped maybe from a website, okay, because now you can see you can see HTML tags. So that should actually it's the sense that okay, this thing was actually scraped from a website. Okay, of course we are going to be importing NLTK. NLTK means it's natural language or toolkit. This is like let me say is it the biggest library or in Python that is used for, or the most used, okay, let me use that word, the most used, or let me say the most popular, okay, or library that used for natural language processing in Python, okay. It actually contains quite a lot of things which you're going to see where I'm importing word tokenize. I'm importing this word tokenize for NLTK. There is corpus, so it has series of other things as well as submodules. It has corpus. So one of the corpus is actually stop words. You must be wondering, what is corpus? Okay, it's very straightforward. Let's just type it here. Okay, corpus. Just very straightforward. Okay, here's it. Okay, a collection of written text, especially the entire works of a particular author or a body of writing, okay, on a particular subject. Okay, so it's just like the body of text. That's what corpus actually means, because when you get to natural language processing, which you can actually use this particular session today, all right, as a fundamental kind of is like a stepping stone as well. I can use that as fundamentals, all right, to like really learn some of these things. These are like words that you hear a lot, in sentiment and I mean in natural language process. It's very common. You hear the word corpus. When you hear corpus, it's just a body of text. Okay, we are importing stop words. Stop words. So these are another thing. Let me just clear it quickly. Stop words are like words that occurs very frequently. Okay, in text. For instance, the, a, of, and, in, is. These are stop words. These are words that occurs multiple times in in a text. Okay. So this is like another thing that you find out or that you'll be coming across. You hear the word stop words, you hear the word corpus, okay, a lot in natural language processing. I'm using natural language processing because that is where sentiment analysis, falls most of the time when you have to look at it. Okay. Then we have WordNet Lemmatizer. We are still importing it from this natural language toolkit. So there is another submodule or like package called STEM. Okay. Now, the thing is, this lemmatizer, there is an interesting concept, especially when you deal with text a lot, of course, in natural language processing, especially. There is something called lemmatization and stemming. Okay, you come across lemmatization, you come across stemming. These are words that are very important that you take note of. Please keep at the back of your mind. There is something I want you to like really pay attention to. It is how exactly are we going to convert this text, okay, into something that your model can actually understand? Because like I mentioned before now, that your model actually understands numbers more, right, than just plain text. Okay, so your model doesn't understand text, so you need to convert this into numbers, which are literally what we call word vectors, right? I mentioned again, you use embeddings. If you are like me, some of these terms that might seem maybe you've not come across them before, okay, try to put them down and try to research about them later on. Okay, there is a reason I'm doing this explanation on each of this module, because when we get to where we are using it, it makes more sense that way. All right. Now there is, of course, feature extraction.text. So there is this count vectorizer and TF-IDF, which is term frequency inverse document frequency vectorizer. Okay, which is like how often does It's very interesting because it's like, how often does a particular word appears in the entire body of text? Okay, don't worry, we'll get to that very quickly. The other thing I do, most times, like just learn some of these things is, of course, the help section of what comes in via your Colab is very important. I said convert a collection of raw documents to a matrix of TF-IDF features equivalent to. So these two things, okay, they're actually like the same. They work similarly. Okay, count vectorizer and TF-IDF. The idea behind it is, okay, maybe you're counting text, okay, maybe you're counting certain words, all right, and you want to look at, okay, how many times does this word actually appears in a body of text. That's what I want you to understand in the basic level. First of all, okay, what we are going to be doing, okay, is like, let's say you have I'm trying to, let's say you have features engineering, modeling, and you have them together, right? You might want to count features. Okay, how many times of features appear in the entire sentence? And then you want to also compare it, how many times of features appear in the entire body of text, in your entire corpus. Okay, so these things are very important. That's why I'm taking my time to explain them. Of course, you must have used your logistic regression, you must have used random forest, you must have used multinomial. If you've not used multinomial, or it's just a naive based approach. Okay, and of course, we import our evaluation metrics, we import accuracy score, F1, and confusion matrix display. We might not use everything, but then I just try to bring in everything to this place. Then we use our train test split, of course, to also split our data set at the end of the day or before training, so that we can have an old out set, okay, for us to test with. Cool. So very quickly, because we are going to be moving fast a bit, let me see if there is any question for me. Okay. Okay, I'm trying to see if there are questions. Okay, I would like to know if it's general thing for most problem statements to require data. That is, in data scraping, something done for most problem statements, okay, or are there readily available data experiment for the problem? So the thing is, for most of the time, depending on what you are trying to achieve or what you are trying to solve, okay, most of the time you will find out that maybe when you're solving a problem that it's not popular or that is not common, okay, you'll find out that you have to source for the data by yourself. You might have to design a survey. You might have to, maybe use some other techniques or other approach to make sure that you get data. For instance, let's say that maybe it was during NSAS and you want to understand, the impact, okay? You might want to understand sentiment around NSAS or the impact on maybe business or something, these are like data that you will not find them readily available. You have to, go look for this data by yourself. Okay, so data most times is not readily available. You have to get them. But of course, there are certain problem statements that you want to solve that, a similar problem statement already exists with a particular data set. So you can use that to maybe just fill it for what you are trying to, the problem statement you're trying to address. Okay. Yeah. Thank you, Papatunde, for providing that clarity. Okay, cool. So we're running out of time, so let me just quickly do this. So now, like I mentioned again, I have my IMDb data set in the same directory, so I don't need to specify directory. I can import this with Pandas. Okay, I think I need to have not run this cell, so let me just run this cell that contains all this library that we are trying to import. Okay, most times, when you're writing your Python, sometimes you want to make things clean as much as possible. So you want to do your import at the very beginning so that when you're just working, you can, just grab all of these things that you've been importing and start using. Some people prefer to import them when you need them. Okay, which is also okay, but sometimes you want to do this so that you have an overview of, all the models, or I mean, all the packages that you're using, in your entire application. Okay, I mean, yeah, in your entire script and experiment that you're carrying out. Okay, so I actually named this as reviews, and then I'm going to run reviews.add. So reviews.add, of course, shows me the first set of 5 rows, okay, in this data. As you can see, you have sentiment, you have positive, negative, positive, okay, and you can see the text here. The text is long, that's why you're seeing these 3 dots, okay, so that is not enough. But the first thing I want to actually understand is to know how many classes are available for me, because merely seeing this, and what we really want to do is to like build a system that can automatically detect whether a text, okay, is negative or positive. It's important for me to know from my training data or from the data set I'm giving, how many positive and how many negative I have, so that will inform me whether I have a class imbalance or not. And then I can cater for that if I want to. Okay. First of all, I want to use SNS, or which is like our Seaborn. I imported Seaborn as SNS, and I'm using count plot to like quickly just visualize my sentiments class to see the sentiment at different, to see the sentiment class, which is like what we are looking at right here. Okay, moving on, I just want to because this is okay, it's purely shows that both of them have the same number of classes, but I just want to be sure. Okay, so I can do reviews sentiment, which is this particular column. Then I can do value count. Then when I do value count, I can get I have 25,000, 25,000 positive, 25,000 negative. So which means that we have a balanced data set. All right, 50% positive, 50% negative. Good. So in this kind of case, when we are using maybe an evaluation metric like accuracy score, we are quite confident, at least not to at least to an extent, that okay, we have a balanced class. All right. Okay. So we just want to take a look at the first text, the first review and the second review, and let's just quickly look at something. What I can actually deduce from here, by merely looking at this, is that we have HTML tags. These HTML tags are meaningless, so to say, to our model. Our model will not find it because we are not training our model how to write HTML, what have you. But so it's very important that we take away this. These are like noise in your data. So we need to get rid of this. Okay, there is another thing we need to get rid of, which is actually punctuation. All right, you have punctuation. You need to actually take care of this punctuation, right? Now, there's also another thing for us to take note of here. I could see, some words are capitalized, some words are not. Okay, so there is need for us to convert everything, okay, to lowercase everything or uppercase everything. Of course, we are going to lowercase it, not just uppercase everything. That's not what we're going to do. Now, these things I've mentioned is something that actually I looked at the other rules, and I actually see that these same problems I've mentioned actually persist. Okay, so which led me to just come up with this list. Okay, which is what you would typically do before you actually, you convert your words to vectors. Okay, before you convert your words to vectors. Okay, this is like a typical step that you have to carry out. Now, this thing I've written here, you might want to take note of this. It's something that for a large number of tasks that involve text analysis, this is something that you will come across. Now, more especially when you're trying to even do maybe something like sentiment analysis, you have a bunch. In fact, this is just part of some of the problems you are going to encounter. It's not all right? And the thing is, it doesn't have to be this way. For instance, this our data set, right, does not contain emojis. What if you have tweets, okay, that contains emoji? Now, there now comes another question. Do you really need emoji for sentiment, or you don't? Okay. Now, there are certain problems that you are might want to address that requires emoji, because we know that emoji is just like when you don't want to talk too much. Sometimes you just, maybe you're chatting with somebody, you just put an emoji. Okay. Now, I'm explaining some of these things because they're very important, especially when you are dealing with sentiment analysis. Things like emojis are very important. So in our case, we don't have it, so there is no need for us to cater for it. Okay. So the first thing we are going to do is remove HTML tags. Okay. The second thing we are going to do is to remove punctuations and numbers. Okay. The third thing we are going to do is to lowercase our text. Okay. We are going to split our words into lists. We are going to remove stop words. Then we are going to perform lemmatization. I will talk briefly about lemmatization because it's a very important technique in natural language processing. Okay, when you have processing, okay, you have processing. For instance, okay, let me use this word that appears here. You have discomforting. This discomforting, it's when you are to split this word, you split it into discomfort. Okay, it can be discomforted. Okay, it can be, you can also, split this into maybe comfort, right? Maybe you want to remove this. Okay, maybe it has some couple of other meanings, but the idea of lemma, okay, is that you have a root word, okay, and then you have some words attached to that root word, okay, which can be, maybe you have like, of course, like this, but let me look at another production. Okay, sometimes you have to be careful because when you actually remove when you actually lemmatize, sometimes the root word can actually mean a different meaning entirely, which is like what it usually is. But of course, you have to still be very careful of how you actually carry out your lemmatization. But the idea of lemmatization is that when you have different words, okay, having the same like when you have different words having the same root word, you want to like just go with their root word, all right, just for the ease of processing. And because one thing with text analysis is that when you are trying to convert your text into numbers, sometimes you end up with a very large word vectors, very large, like very, very large word vectors, embeddings that are very big sometimes. And this is where the idea of word vectors, word net, and glove text, fast text, all of this thing comes in. Don't worry, we're not going to be doing all of these things today because these are like, things that helps you when you are actually, doing NLP, they help you to like build your word vocab, your vocabulary is very, very fast. You don't need to like build your own from scratch. You can leverage on what already exists. So there comes another word. If you take note, vocabularies. Okay, so these are like the words that you hear a lot when you're dealing with sentiment analysis. Okay, cool. So let's go right through all of these steps that you've seen right here. Okay, and then I actually wrote a function right here to perform everything, but I'm going to be walking you through one after the other so that you can understand what we want to do. So from here, I'm going to just put rev, okay, so that we can actually save one of these things, which is the text inside rev. Okay, so when I just print rev, I should get the movie review, the second movie review. Cool. So we are going to be using this to like apply some of these things, and we're going to see how it's going to work. Okay, but before we go ahead to start the preprocessing, I'm going to import or download some of these things using NLTK. I'm going to download stop words. I'm going to download WordNet. I'm going to download this OMW. Okay, so these are like just like WordNet stuffs. So the idea of the WordNet is for us to like really use the lemmatizer at the end of the day, because WordNet actually have it has a lemmatizer class. Okay, let me run this. I already explained the idea of stop words. So now let's do this. When you actually have Beautiful Soup, okay, Beautiful Soup is a very common library when you are dealing anytime you do scripting in Python. I'm sure you come across Beautiful Soup. Yeah, I'm sure you come across Beautiful Soup. Okay, so what we actually did was ref. So what we want to do with Beautiful Soup is that we want to remove HTML tags. That's what we want to do. So let me just run it here. So as you can see, it's going to split. It's going to remove all the tags. Can you see? Where is rev before now? Let's compare it. Can you see? The Beautiful Soup has removed, all the HTML tags. So we don't have any HTML tags anymore. So we've only gotten the text, okay, from this rev. So we are left with text without tags, without HTML tags. That's the first thing. So I'm going to name this rev without HTML. Oh, sorry. I need to I need to equate this to something. Okay. So we are done removing HTML tags. The next thing I want to do is to remove punctuations. Okay. We are going to be using the regular expression library, and we're going to be removing we're going to be removing punctuations. So what I'm going to do is that I'm going to, this one that I've actually removed I've removed the HTML tags from is one I'm going to use. So I'm going to do this. Then okay, so very quickly, this thing is going to remove. Can you see? You don't have any punctuation here anymore. So this is what we are using. Okay, we are actually, taking away all the punctuations. So let me do something again. I'm going to save this as rev without. I'm going to save this as rev without punc and numbers. Okay, so let me save this. So the next thing we're going to do is to lowercase our text. Now, I should mention that, the way we are doing this is very important that you follow this approach. Why? Because the thing is, let's say that you actually, splitted the text before you lowercase it, or before you remove punctuations. It might be very difficult because the complexity of the computation might now be increasing very fast. Okay, it might be increasing. You might not be able to really capture it at once again because you have a lot of codes to write in order to get something done. So it's important. And sometimes it's very important that you follow, a particular step so that something does not reappear at the end of the day. Okay, that's why it's very important. Okay. So review. So we want to lowercase. So before we actually see this, I'm going to, first of all, do this. So can you see we have everything lowercase? So I'm just going to do rev lower so that it is clear on what we're doing. Okay. The next thing is we are going to split. All right. I'm sure you must have used this thing before. Now, why we want to split? Now, okay, maybe I should mention again. The reason why we're removing the HTML tags is because this does not have anything to do. It does not actually add anything to our model, right? It's just noise. Okay. So we need to remove it. There is no information this has to provide for our model. So we need to get rid of it. We are removing punctuation marks, all right, because at the moment, what the kind of task we are solving does not actually involve anything like maybe we want to understand whether something is a question or not, or maybe there's full stop somewhere or not. We don't want to deal with that, so we are taking it off. We are lowercasing so that when you have a word like tradition in capital letter and you also have another word tradition in lowercase, okay, those are two different words. From your computer see them as two different things, but we need to tell our computer that when we lowercase both of them, okay, they are the same thing. So when you lowercase both of them, your computer can see them as the same thing. But the moment maybe the first letter is capital, no, that way your model sees both of them as different things. Okay. So because we want to make them the same, so we have to lowercase everything. So I'm going to run this. Then of course I said we want to split, so we can do, okay, so I've already copied this. So we are going to do, and of course, when you apply split on a string, what does that mean? It means that it's going to convert it into a list. All right. So this is what we are doing for each of our rows. So can you see now? So look at, these are stop words. Okay, is a, okay, a, right? A of, these are words, and these are words that are occurring very frequent, of, the. So these are like the stop words that we need to take away because they occur very frequently. And this time we don't need them because our model will not learn anything from them. So we need to get rid of them. Okay, cool. So very quickly, we're almost done. We're almost there. So just stay with me. Then you have rev splits. Okay. So this is like some of the things you have to do when you are dealing with text analysis. Very important stuffs that you have to carry them out. Now, aside from that, you then lemmatize. All right, you lemmatize. So I'll just copy this lemmatize function. I'm going to show you. The thing is, you might not really see any any significant difference there. And that's because the words that are being lemmatized are not that frequent. They are not that common, okay? Or maybe it can be like maybe 5 words or maybe 2 words in a sentence. And it might not even find any word to lemmatize in the sentence. So you might not see anything that was changed significantly. So I'm going to do this. Let me just take away this so that we can just spit it out. So review, then we have stop words. Okay, so we've already downloaded the stop words, right? So we've downloaded it here. So this is supposed to run without further. Okay, let's see. I've actually imported stop words, but I don't know why this is giving me stop words is not defined or something. Stop word is not defined. I've imported, we've downloaded stop words, and we've also imported stop words, right? We've also imported stop words. So I'll just run these two again and try to see. Oh, stop words is not defined. Okay. It's not iterable. So what's supposed to happen? It's supposed to be stop word. I've tried this. Okay, sorry. This is what I'm supposed to do first. So I knew it. Okay. So from these stop words, I actually need English stop words. So let me run this now. Okay. So now it has actually lemmatized this word for us. You might not really notice, but if I see anyone that has lemmatized, I will actually let you know. This polary, I'm sure it must have lemmatized this word, that word polary. I'm trying to see which other word has been lemmatized. Okay, maybe we cannot see it, by me looking at them. W, okay. Okay, so I wanted to see the words that were lemmatized, but then maybe we are not able to see those words specifically at this stage. But what we can do is I can actually say, so this is not okay, so we are lemmatizing, all right? Then as we are lemmatizing, we are removing stop words. If you are to rewrite this function, you will say for, all right? Let me say for I in rev splits, okay? In rev splits, okay? For I in rev split, okay? If W not in stop words, okay? W if I not in, I just want to replicate this thing so that, okay, if I not stop words issued, we don't want to lemmatize stop words. That's essentially what we're trying to do. Okay. Okay. Then I'm just going to print I. Okay. So it prints the entire word, but then we're still not getting if I not in stop words. So you should lemmatize, okay? So we cannot really get the one it's actually lemmatized. But one thing we are sure of, all right, is the fact that we are not lemmatizing stop words, okay? Because we don't need stop words. So that's why we are doing this, if I not in stop words, because we don't want to lemmatize stop words. But we are still not even getting, vividly the words that were lemmatized. But that process is very essential. Like I mentioned before, sometimes you might not really get words that, lemmatized easily. Okay, you might have to like carefully look at the words that were lemmatized. Okay, so just for us to save some time, I've actually written this in an entire function. All right, and what we need to do is just run the function. Okay, and in this place we are actually creating a data set, a training data set, and as we are creating the training data set, okay, as we are creating the training data set, okay, we are also applying this text transformer. Okay, we're applying this text transformer. Okay, so that's the function to each of the text. Now, another way for doing this, for some of you who are very skilled with pandas, another way of doing this, of course, you know that you can actually apply, okay, when you apply this function, okay, on using pandas apply, or no, Python apply, you can actually apply this on a data frame. Okay, so instead of doing this way, then after you're done applying it, you can convert the entire series, okay, the Pandas series to a list. Okay, so I'm just going to do this, and it's going to take some time, maybe a few seconds more, and at the end of the day, if I print my train data, okay, I'm going to get it in this format. Okay, I'm going to get in this format. Now that I'm getting it in this format, okay, sometimes don't mind the look. It might look very different from yours. Actually, it's supposed to be like splitted. Okay, supposed to be like splitted. So after that, what we are going to do is to actually use our count vectorizer. So the count vectorizer, basically what it does, okay, as the name implies, is just like it's the one helping us to convert, okay, these words, okay, from normal word, okay, to numbers, something that makes sense. Is converting them. Now, the way it is converting them is doing this logically. All right, there are several ways to really build this thing ground up. You can either count the number of words and use that, how many times the number appears, which is like time frequency, which is like what this next guy is doing. Okay, now I deliberately put this here, okay, because I just only want to like use this one. We can come back to use this one, okay, but for now I just want to make things as simple as possible. Okay, you create this count vectorizer, then you fit and transform the train data, which is the one that we actually create from this place. Okay, so, and I can save it as X, right? Now we already have our X, and you know that from your normal machine learning approach, you have your X and your Y, right? So yeah, let's quickly move to this place and define our Y. We already have our Y. Our Y is sentiment column, which is positive and negative, right? Now, there's something I'm doing here again. Like we've always said, like we've established, that your model does not understand, text. It only understands numbers, right? You have text here again, and that is your label. So we need to convert this label to, numbers. Okay, so for doing that, if you don't get anything today, one thing I want you to understand is that when you want to actually train anything that's in natural language processing, okay, you convert the text to numbers because your model does not understand those texts. Cool. So that's what we're doing right here. Let me just run it. And then we can actually build our train template using this thing. Okay. I'm sure you're familiar with this train template. There is no need for me to actually stratify it. I just said to put this there. There's no need for me to stratify it because it's a balanced class. Okay, so it's a balanced class. I don't need to stratify. Use 70% for training, 30% for testing. Cool. So this thing is telling my session crashed, and that is because I've actually overloaded my RAM. Okay, I was not cleaning the RAM, so I'm just going to start again. I shouldn't run that that particular cell twice because I've loaded lots of stuffs on memory. So that issue happens when you've loaded a lot of variables in memory, variables that are very large, containing large values. So that's why the RAM actually crashed. Okay, since I've done this, I'll just quickly move to this guy. I'll just quickly move to this guy where we are applying our function. So let me do this. Okay. And as that is getting done, we can run this count vectorizer. And from the count vectorizer, we can actually run, run our np.array, okay, to create our, to actually replace our positive with 1, our negative with 0. That's essentially what we are doing here. So we want our model to see positive sentiment, like to see the label positive as 1 and to see the label negative as 0. Okay, so let's just give this a few more seconds to load, to finish its thing. It should finish very soon, or in a few seconds. While that is loading, let me just continue because we run past our time. Okay, then of course you actually do this. Okay, this is still running. I wonder why this is still here. Okay, so when that is done, there are two things we can do. Okay, maybe I shouldn't have used this approach because it makes it look as though it is too big. So let me do something very simple. I'm going to do something very, very simple. Okay, so we have our X string. Now, when you check our X string, okay, let's quickly check. When we check our X string, you'll see something. Can you see? 0, 0, 0, 0, 0, 0 everywhere. Most times you get this very sparse vector. Okay, I mean like a sparse matrix rather. Sometimes when you are creating embeddings or word vectors, sometimes you get, sometimes when you are using things like maybe WordNet, okay, or glove text or fast text or something, those ones have been pre-trained. They are pre-trained embedding, so we don't need to use our count vectorizer for what we are doing again. Okay, so let's just move on to training our model. Okay, so let's just move on to training our model. We can do logistic regression. Okay, actually for something very fast, let's try our multinomial for something very fast. Okay, let's try our multinomial. I'm sure you know how to train a model, so and I'm praying that this thing does not actually get filled up. Cool. So as you can see, so let's print our accuracy. First of all, 0.49, okay, not so good. That's 0.5, very bad, actually, because it's very, very low. Okay, the other thing we can do, all right, in order to like really attend to something like this is to actually, use maybe TF-IDF, okay, and when you try to use TF-IDF, that should actually, give us some level of a good degree when it comes to our accuracy. Okay, but at this point, before I try this out, so let me just, so this is like this is what you do typically, and let's just see what our model has predicted, and what our X test is, so that we know that, okay, what exactly are we doing? So I'm not going to use X test. I'm going to use so there should be okay. I'm trying to see how to pret. Let me just do pret first of all. Okay. Then let's see. Coming. This is our X, right? So let's see how to take our X back, where is our fit under transform. So it is CV. Okay. So there should be a way for us to transform this back. So let's see. Okay, so I'd actually remember how to like take this back, but it should be like inverse. It should be like an inverse of the fit, inverse transform. Yeah. And then we can pass in our X test. So when you do something like this, it should actually return the inverse, all right, of, or what this thing was actually about before it actually transformed it. I don't know if this makes sense. Okay, so when you actually read this, so this is not that straightforward because it's a text that is concatenated, but it is like, assume previous post, okay, came exec production. This exec, I'm sure that it has been lemmatized, okay, production company, blah 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 blah. And when you check it, let me scroll up. I don't know why this actually came down. I didn't ask it to come down, so let's scroll up to the top. Okay, and you actually see this. You can see really liked Summers. Okay, now really liked Summers. Okay, looking at this, because you can see the word liked, okay, and you can see the that word liked, interest, interesting, okay, these are like good words, so automatically our model marked it as 1. Okay, so like that, so your model will assign a certain label, which is like what your model feel it should be based on the the training data that we've actually used to train the model. I just wanted to like show something very rough and quick right here, but what I'm saying is that when we are done, I tried to use the CV, which is like the count vectorizer. I use the inform transform, okay, to transform back the data. I told you that it's converted that data, okay, the data we applied into it, into numbers. But this time around, I want it to convert it back to text, which is like what it has done. All right. So so that I can actually see the performance, of the model, basically, and see some words, not the performance of the model, but just to see some words, if they are correctly matched or not. Our accuracy is very low. So then now comes how to improve your model, okay, which another thing we can try to do now is TF, IDF. Okay, let me stop here and try to see if I can attend to some questions, if anybody actually have. Okay, cool. So, okay, so let me ask, anybody have any question? This is something I want everybody to.
Thank you very much, Lawrence. So I think we have some
Yeah.
questions here, so let me please help you to highlight them.
Thank you.
Okay, I've seen one from ADBC. And it said,
Okay.
what is the implication of a balanced positive and negative sentiments on the accuracy score?
On the accuracy score. So when you have the positive, so it does not have, that's what I said initially, it doesn't, because it's a balanced class. Let's assume it's not balanced. Accuracy, in fact, most times people try to run away from using accuracy, all right, in order to evaluate machine learning models. But in a place where you have a balanced, okay, where you have a balanced class, okay, where your class is balanced, just in this case, where you have 50% of negative, 50% of positive, you are still in a good position, okay, in order for you to use accuracy score. So it does not really have an impact. Your classes does not really have an impact because you have a balanced data set.
Okay, so thank you very much. Another one from Nobu. I think this is the last one. Can I run this on PyCharm?
Yes, sure. You can run it anywhere. You can run it in any environment you want to run it. But of course, when you are doing data science or tax, you want to experiment a lot of things. Look at the way we quickly, brought out this part of the notebook, right? Where you have our function and we started experimenting with things. We started bringing things out, right? If you are in a PyCharm environment, okay, you might not be able to like do that because that means that you have to be running the notebook one after the other, one after the other, one after, like this entire script again and again and again. So it's not really good for experimenting. That's my issue with not my issue, but that's like the issue with PyCharm. Okay, but of course it's still the same Python script. You can run it in any Python environment.
Okay, yeah. So another one just came in. Another question came in from Kelvin. Said, must the training and testing ratio be 70-30?
No, it doesn't have to be. It doesn't have to be. It depends on the what you want to ensure is that your model have enough data, all right, to learn, and you on the other hand, you have enough data to actually test the performance of your model out. So sometimes people use 80-20, that is 80 for training, 30 for testing. Sometimes you might want to use, you want to use 70-30. So it depends on how large your data is. But most times this is not really an hyperparameter, really. Yeah, it's not an hyperparameter. So, but just make sure that your model have a decent amount of data to learn from, and at the same time you have a decent amount of data points, okay, to evaluate your model with.
Thank you very much, Lawrence, for this detailed class section. Okay, so with an emoji, can you please let us celebrate the facilitator with a favorite emoji? He has done justice to this topic, and I'm sure you can bear me witness. So just let us see your emoji. I think a question just came in, and then I would like you to respond to that before I finally close, or before we finally close for today. So is it compulsory to use a lematizer?
Well, like I mentioned before, these are like approaches that are proven to, to give a good performance to your model. Sometimes you want to train your model without even doing any lemmatization. And the funniest thing is your model can even perform better without lemmatizing. But of course, several works have actually shown that when you lemmatize, you tend to get better performance. Better performance because you have lesser vectors. Like I mentioned before, when you are converting text to numbers, you generate very big amount of vector, all right, very big word vector. So, but when you lemmatize, that word vector might reduce, okay, which can also, help you to increase computation, okay. So yeah. So it's not compulsory. But then it's a good to have thing that can definitely help your model performance.
Okay, I think we have a lot of questions here. So because of our time, we'll be dropping a Telegram link for you to. I'm sure everyone who registered, we have sent the Telegram link for AI Everyday, where we are going to continue the conversation. We cannot actually end the conversation here. It's a community, and we need to continue to learn together. So our internship opportunity, we dropped the link to for you that asks for the question on that, and then also to get updates on trainings. So you need to be a member, and if you are yet to be a member, a link will be dropped for you so that you can actually be a member of DSM. So thank you everyone for joining. I really appreciate this. Also, you can watch this again and also share with others via our YouTube link. Okay, so you can watch this again and again and again. So don't forget to join the AI Everyday Telegram group. Okay, and don't also forget to become a member of DSM because there are a lot of opportunity attached. So once again, I want to say thank you everyone, and I want to say special thanks to Lawrence for honoring the invitation and for being selfless to impact our generation. So thank you everyone. Okay, and do enjoy the rest of the day. Goodbye.
Yeah, goodbye.